We can run multiple instances of diagnostic microservices. Essentially, we can scale individual microservices and make more efficient use of resources. This video is the first part of complete series on microservices architecture. In this video, we will cover first the issues with old style monolithic architecture that required a fresh approach. Second, what are microservices? Third, the concept of microservice architecture and why it is essential. Then we will also explore the principles and key characteristics of microservices architecture and how these characteristics help us overcome the problems associated with traditional monolithic architecture. Before the introduction of microservices architecture, applications were typically designed using monolithic architecture. In monolithic architecture, all components of software, including the user interface, business logic, data access code, and database operations, are mixed together and managed as a single code base. This approach led to various issues such as deployment difficulties, scalability problems, inefficient resource usage, maintenance challenges, longer development cycles, technology dependencies, etc. To overcome these challenges, microservices architecture emerged as a revolutionary approach in the field of software development. Its purpose was to address limitations associated with traditional monolithic architecture. Before we discuss microservices architecture, we first need to understand what a microservice is. So, what is a microservice? A microservice is a small independent component of an application. It is designed to perform a specific task and it possesses its own database and business logic. What is a microservice architecture? An application designed with a microservices architecture contains a set of smaller microservices, each running independently and communicating with each other. Each microservice performs a specific task that is often a business feature of the application. For example, if you are designing a hospital management system using microservices architecture, different functions of the hospital management system will be handled by different microservices, such as a microservice that manages the patient data, another microservice that handles appointments, a microservice responsible for billing and payments, yet another microservice dedicated to managing medical supplies and inventory. There can be many more microservices in this application, but each one is responsible for a specific function of the application. These microservices often communicate with each other through well-defined interfaces, typically using lightweight methods like RESTful APIs. So, designing an application with microservice architecture is like constructing a machine where each part works differently but all together achieve a common goal. Now, let's look at the characteristics of microservices and their advantages in microservices architecture. First, independent microservices and decentralized governance. Applications designed with monolithic architecture often face a problem known as single technology platform. It means if you started building an application using a certain technology like Java 8, you were stuck with it for the entire project. You couldn't mix and match technologies like Node.js, .NET or C++ for different parts of the application. However, microservices architecture solves this problem. In microservices, each part of the application is called a microservice and handles a specific job and works independently. This means you can use different technologies for different microservices. For example, one microservice can use Java, another can use .NET, and another can use Node.js. Consider a hospital management system built with microservices. In this scenario, there is a separate microservice for each distinct function of application, like patient records, billing, appointment scheduling, and inventory management. The patient records microservice might be developed using Java, billing microservice with .NET, and appointment scheduling microservice with Node.js. This approach is called decentralized governance, which means that in large projects, each microservice has its own team. Each team has the freedom to choose the best technology, database, and other technical aspects for their microservice. Idea behind is that the team responsible for a microservice will make the best decisions for it. The flexibility of decentralized governance is possible because microservices are designed to work independently, unlike monolithic systems where changes in one part affect the whole system. Decentralized governance in microservices empowers teams to make the best technological choices for the specific services, making development more efficient and faster. Second, specialized microservices are easy to maintain. Each microservice is designed for a specific set of tasks. For instance, the patient records service is solely focused on managing patient data, making it more efficient and easier to maintain. Meanwhile, the appointment scheduling service performs tasks related to appointment scheduling. Changes or enhancements in one microservice do not disrupt the other microservice. Basically, each microservice is specialized for a specific task and runs independently using its own tech stack. An update or a new release of a microservice will not break other microservices because you only need to test the microservice you are changing. The codebase of other microservices will be different and will not require retesting. It makes maintenance of the application easy and also makes the life of the developer easier. This is another advantage of independent nature of microservices. Microservices and flexible deployment. For an application built with traditional monolithic architecture, a minor update or fix required the complete redeployment of the entire application. This approach is problematic because it demands comprehensive testing of the whole application for every update, leading to prolonged development cycles. However, the shift to microservices brings a significant change known as componentization via services. Unlike monoliths, in microservices, business functions are modeled as independent microservices. This structure allows for the deployment of individual microservices without affecting the deployment of the entire application. Imagine a hospital management system built with microservices. In this system, different services like patient records, appointment scheduling, and pharmacy management operate independently. Each service has its own database, ensuring that updates to the pharmacy management system don't impact patient records. If the appointment scheduling service needs an update, it can be deployed without redeploying the entire hospital management system. This reduces the risk of system-wide failures during updates and also shortens the development cycles. Since each microservice runs in its own process and with its own database, it might be on the same PC as the other microservices or on a different PC. This ensures loose coupling between microservices and allows them to be deployed separately. Fourth, scalability. In applications designed with monolithic architectures, a single process uses CPU and RAM for all its components, irrespective of each component's individual needs. This one-size-fits-all approach can lead to inefficiency. We cannot scale individual components or allocate more resources to a specific component. Microservices architecture offers a solution to this problem through its componentization via services attribute. In an application designed with microservice architecture, each microservice runs independently and communicates with other microservices through APIs. We can run individual microservices on separate VPCs or even scale independent microservices by running multiple instances of each along with a load balancer. Consider a hospital management system designed with microservices. In this system, each service like patient record management, billing, and diagnostic services runs independently. The billing service, which may not require extensive computation, could be allocated minimal resources. In contrast, the diagnostic services, which might involve complex data processing, can be given significantly more resources. We can run multiple instances of diagnostic microservices. Essentially, we can scale individual microservices and make more efficient use of resources. In conclusion, microservices architecture not only addresses the problem of inefficient compute resources, but also provides a flexible, efficient framework for building scalable and resource-optimized applications. Fifth, resilience and reliability. Both resilience and reliability come with microservice architecture. This architecture divides a system into independent services, each handling a specific function. This makes the application resilient. If one microservice fails, it doesn't bring down the entire system. Imagine a hospital system with separate services for patient records, appointments, and emergency care. If the appointment service fails, the patient records and emergency care services continue functioning, ensuring critical hospital operations aren't disrupted. This can be achieved in microservices architecture because each microservice runs in isolation. Microservice architecture makes the application reliable in handling failures. We can run multiple instances of the same microservice to provide backup in case of a failure. For example, if a microservice handling emergency care fails, another backup microservice immediately takes over, ensuring continuous patient care. This modular setup enhances the system's overall reliability. To summarize, microservices architecture represents a paradigm shift in software development, offering modularity, scalability, and flexibility. It breaks the application into several small microservices, each mapped to a business function of the application. It offers various features and advantages like flexible technology use and decentralized governance in application, simplifies the maintenance of the application, makes deployment easy and quick, and reduces the development cycle. Makes the application resilient and reliable. It is easy to scale applications. You can scale individual components of the application by scaling some microservices only. So, in a nutshell, microservices architecture is crucial for efficient, modular, and scalable software development in today's world. In the upcoming part of this series on microservices architecture, we will discuss communication between microservices, focusing on how services communicate with each other. This includes synchronous communication such as REST APIs and asynchronous communication such as message queues and PubSub. Service discovery in microservices, covering how microservices discover each other. Third, API gateway in microservices architecture. Last but not the least, service mesh. So stay tuned for these topics in upcoming videos on microservices. Thank you so much for watching.